the questions keep on arising as we go through exact differential equation. And the first question is solved, alright, that is, in case it's not exact, then we say that, oh, let's go for the integration factor for the exact differential equation to make it exact to find the general solution. Alright. But that one is if only, that one is having a limitation that if only it's dependent on x or y. But what if the integrating factor is dependent on both x and y? Question mark. Alright, so it's going to be interesting in cases when the integrating factor depends on the variables. In fact, this is what I'm sure most of you are waiting for it. I'll give it to you and you will love it, alright? So, in cases when the integrating factor depends on both variables, it is determined by recognizing certain groups as differentials of known expressions. Certain groups as differentials of known expressions. Now, there are about 8 formulas that we are going to recognize. Alright, and I may not like you to chew it. I may not like you to chew it. No, that is not going to help you. That is not going to help you to memorize it. But understand it. And how do you understand it? By knowing how to come out of it. Alright. So, I'm going to start with this. Before the proof, I would like you to be okay with this. If I have x, and I want you to differentiate s, I know when you differentiate s, you get one. But here, I want you to do this. To differentiate s, I want you to write ds. Yes, just write ds. You have differentiated it. If you have y and you want to differentiate, just write dy. Yes, that is the differential form. That is the only thing I want you to be doing here, and the rest is just application of knowledge. So, okay, differentiate x, that is the x. Differentiate y, that is the y. That is all. That is all. Yes, that is all. Alright. So, since that is all, so let me write it so that you're not confused. To differentiate this is yes and b. And to differentiate y is dy. Now, first proof. We are going to recognize certain groups as differentials of known expressions. But before that, you need to understand it. If you have a derivative, here, don't forget your product rule and your chain rule. You have the derivative. Let's start with this first. Now here you have to differentiate this and this. But know that this is two functions being multiplied. So that is going to be a product rule. So if this is a product rule and you have to differentiate, what will you do? What will you do? But don't forget, I said to differentiate s, just write yes for me. I will be okay with it. To differentiate y, just write y for me. So product rule, leave the first one, bam. Differentiate the second one, which is y. So to differentiate y, you write dy. It's not a formula you should choose. No. Plus Differentiate, now leave the first one, differentiate the second one. So now you will leave the second one to differentiate the first one, and that is dx. And that is dx. And that is all. That is all. That is all for the first part of the expression. So this is one of the expressions. In fact, there are 8. 2. The derivative of x over y. This is two functions being divided. That is quotient rule. So we do quotient rule right now. Let's do quotient rule. You will have it. Low the high minus high the low. Square the bottom and the way we go. Don't forget that. I hope you haven't forgotten it. Alright. So low the high, that means you are differentiating the top. The high, and when you differentiate s, you get this. Minus high the low, that means you are leaving it down. Low the high minus high the low. Square the bottom. You square the bottom, which is y, and the way we go. So that is the second expression. That is the second expression. So you see, these things you can derive it, and if you know how to derive it, you don't need to chew it. Alright, very good. So that is the second part. That is the second part. That is the second part. I love this. So bam. Then we move to the third part. Now, the only thing I want you to recognize is this part. Once you know this part, you can get this part easily. And that is only and that is the only thing I want you to know. Know the left hand side. You can get the right hand side. Okay? Very good. Because knowing the left hand side is not difficult. Alright. Now, first thing, the first one is that two functions multiply, which is x and y. Second one is that the function is down divided, but the x is on top. Thirdly, the y will be on top and the x will be down. Same way, product quotient rule. Low the high minus low the high minus high the low. Square the bottom and away we go. That is the second expression. Always don't forget the left hand side. Divided by the dividing, one x is on top and one y is on top. Now watch. The one that y, then you also know the technique. The one that y is down is one that you square it. The one that s is down is the one that you square it. Let's continue on. Fourthly. And that is when we have the lean. And that is when we have the derivative of lean x over y, which is this. Wow. This is not difficult. Differentiation. Let's go. You can see that this is a function instead of another function. So the lean, when you are differentiating the lean of something, what do you, or lean of a function, how will you do it? 1 over the inside. So it's 1 over the inside, and the inside is x over y. And this is the same as y over x. So y over x. So 1 over the inside, which is the same as y over x, times the derivative of the inside. Beautiful, let's move on. y over x. Now, the derivative of the inside is going to give you a quotient rule. Low the high minus high the low. Square the bottom. And the way we go. In fact, we are going. We are gradually going. So to simplify this will clear one of this. Alright? And this will go and multiply this. So you are going to get y dx minus x dy. All this over this times this, which is sy. Very good. So that is that. That is that. That is that. You see, once you know this, getting this, it is previous knowledge. It's a previous knowledge. Okay, so now the first one, x is multiplying the y. The second one, we have x over y. The third one, we have y over x. The fourth one, we have x over y. It's not difficult. Alright. So that is that. Now we are going to clean it. So this is the first four, and we are left with the last four. Is there anything? Is there any question? All right. Anytime you have the x square, you know that it's going for this. You having this, you know that it's going for this. All right. But when you have the case when you have x and the y, the product of the x and the y, then quickly you remember yourself that it will be the link x over y. See, maybe if you have forgotten, you can prove it and see it. All right. So let me clean this. Pim, 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 pim. 5. The fifth one, and that is the derivative tan inverse of s over y. So don't forget, after the product of s and the y, you go for s over y, you go for y over s, then the link of s over y. Now the emphasis is still on the s over y, not the y over x. Watch me, not the y over x, but the s over y. So after taking the link of s over y, then you come to take the tan inverse of s over y. So it's still the s over y. How do we do this? Quick. You know that the derivative of tan inverse of u, tan inverse of u, the derivative of this is 1 over 1 plus u squared. So now the u is s over y. So what do you think here will be? Here will be 1 over 1 over 1 plus s over y squared times the derivative of the inside times the derivative of the inside, which is s over y. Very good. That's exactly what we are having there like that. So you have to be, that's why you can never do ODE, or you can't be a good student of ODE without your idea in calculus 1 and calculus 2. Charlie, if you have forgotten it, quickly chase it. All right. So we have that, and this is going to be 1 over 1 plus s squared over y squared. Take the derivative of this. Low the high minus high the low. Square the bottom. And the way we go. You see that? The what is left is algebra. It's not even continue. Here, let's try to achieve the same denominator. The same denominator. So here we get 1 over y squared over y squared plus x squared over y squared multiplied by so this here we're going to get 1 over, I don't want to skip anything, y squared plus x squared, the whole of this over y squared. So we get y dx minus s dy. All this over y squared. Now, those are these going to get be the inverse of that. Okay. So we continue. We are going to get y squared over, let's write it well, x squared plus y squared. Then it's going to multiply y dx, we will get it. Alright? Have you choose the formula? Oh, Charlie, you kill yourself. Watch. You can prove it. Minus x dy. Okay? All this is over y squared. Pium. What is left? And that is wow, fantastic. So you see, the one that we have on the denominator here to be sy. To be sy, that is the derivative of ln s over y. But the one that we have s squared plus y squared or y squared plus s squared is the tan inverse form. Is the tan inverse form. That is how you get it, alright? That's how you get it. That's how you get it. And knowing that the reason why we are here is negative is because of the quotient that is appearing here. Alright? That's how you get it. The one with tan inverse of s over y is where we have s squared plus y squared. Because now, apart from this s squared plus y squared in the denominator, there's another one that is also having s squared plus y squared in the denominator. But the top here differs. The top here is not a quotient rule. Directly from this, as you can see, and that is the sixth one. So I want to name this one. I'll try to manage it for that. Which is now how to take the derivative of this. 1 over s squared plus y squared. The derivative of the inside. So you can see where the derivative of this is coming from. You don't worry. Let's end it. In fact, I'm too excited. Differentiate this. Now, this is going to be s squared plus y squared. But differentiate this. You get 2s. Don't forget we are differentiating as respect to. I'm coming. Don't forget that here we are differentiating x squared. Alright. But as I said, this is like a general volume. So you differentiate, you get 2s, then you differentiate the inside. And when you're differentiating s, I'm saying that if you differentiate s, it's 1. That's why s squared, when you differentiate, you get 2s. But here I'm saying that you are not doing it just as normal as you do. Here it's a general problem. Multiply this by this. You differentiate it as respect to s, alright. But multiply this by this, you get 2s. Differentiate the inside, which is ds. Plus here, multiply this by this, you get 2y. Then differentiate the y, you get dy. Wow! So you can see that here we have the denominator to be x squared plus y squared. In the same way, here we have the denominator to be x squared. We have the denominator to be x squared plus y squared. But take the numerators. So if you have this, no one should whisper to your ears that this, the one on the numerator here, is coming from the one in the tiny inverse, because this x squared plus y squared is only appearing in the one in the tan inverse and the lead. But here is tan inverse of x over y, whereby the quotient root of x over y is the one on top here. And with this, when you differentiate the inside, that is what we are going to get here. So definitely, whenever you have this, go straight that is going to be the one of the tan inverse. Very good. So that is the proof to that one. Now let's go to the seventh one, and you will love it. Trust me. Okay. Seventhly, as somebody says, we have firstly, secondly, so seventhly. Alright, so let's move on to the seventh proof. Seventhly, to the seventh proof. Alright. Don't mind me, okay. Okay, now this is mean, and there is a function inside of another function, right? So this is 1 over sy plus 1. Then you take the derivative of the inside, which is very good. Now, you move on to differentiate. This is sy plus 1. But what will be this? Don't forget that this only is a product rule. Yeah. Product rule, that is that. Very good. So let's move on. We know that when you differentiate this one, it's 0. So now you think of it. Just do the product rule and go your way. So leave this, differentiate this, you get y. Plus, leave this, differentiate this. Over, hey, there is no over. We are doing product rule, not quotient rule. Alright. So that is that. And when you multiply this by this, you get very good. So that is the seventh proof. So this is also x1. Now we have the one which is having a denominator to be only x1, but that is the lead x over y. Don't forget that. But this one is xy plus 1. Alright? And the one which is xy plus 1 is going for lead xy plus 1. Don't forget that. Never forget that. Alright. I think we are left with the last one. We are left with the last one. And that is the eighth part. That is the eighth part. Okay. Still differentiation. Now, we have to differentiate the general power rule, alright? So the 2 here will multiply the whole of this. X squared plus y squared. Then you differentiate the inside. So the derivative of the inside will be x squared plus y squared. Very good. So here you get 2x squared plus y squared. Then here, when you differentiate, you get 2x, then you differentiate the inside, you get ds. Oh, we don't forget that. Alright. Plus, and the inside, you get dy. So, here we get 2x squared plus y squared. Then 2 out here, we get s ds plus y to y. 2 times 2, we get 4. So 4s squared plus y squared. S ds plus y dy. Oh, marvelous. My goodness. That is also the 8 Philip. Is there anything like 8 Philip? So that is the 8. So that's the 8 formula. That is the 8 formula. So that is all for that when the oh yeah, that is all for that. Alright. So I will encourage you to know the left hand side. And once you know the left hand side, the right hand side is just bonus. If only you remember all that we have done. Alright. So we are going to our next video, and I would like to introduce to you some more. In the next video, we are going to solve some questions deriving from this idea, and trust me, you are going to love it. All right, and I will be picking the questions from our lecturer's book, and that is a book written by Professor Esiedu and Mr. or Dr. Ali. Dr. Ali. I will be picking questions from their book under the tutorial set. Right? So I think we have about 6 or 5 questions from there concerning this idea, and we'll be looking at it. I may not solve all for you. I will leave some of them for you to also go and do it by yourself. Alright, so until then, thank you for your time, and wish you subscribe to our video tutorials channel, that is Math Expert, and trust me, we have a lot for you. Just go to YouTube and search math, don't add s to it, Math Expert, and you are going to love it. Thank you, and bye bye.